Welcome to the proof practice video for geometry right before your proof test. So this is going to help you kind of run through all of these proofs and make sure you know what you should be doing and what the expectation is. I'm going to let you know now that it is very possible that we may have some extra steps along the way beyond just the numbers that it says it will have for various reasons. But if you do your proofs this way on the test, you will be solid. And remember, the test is basically these proofs. And so if you get these down, then you should be solid. So starting with our first one, we have proof number 1. And we are given that 1 and 3 are vertical angles. So keep in mind that you always start every proof with the given. And so no matter what, you guys should always get at least 3 points on proofs because you can tell me the given and you can tell me what you're trying to prove. So 1 and 3 are vertical angles because that is given. And we are trying to prove that 1 is congruent to 3. So if you think about it, if I'm trying to prove 1's congruent to 3, I can say that 1 and 2 form a linear pair because they have these little arrows here. And then I can also say that 2 and 3 form a linear pair because of these arrows. And then they share that angle too, so then I can do some math with that. So I'm going to start by saying that the measure of angle 1 plus the measure of angle 2 equals 180 because of the linear pair theorem. Now, keep in mind, I want to put the measure of angle 1 because I'm talking about the actual number for it, not just naming angle 1. If you just put angle 1, technically you're just naming the angle, so it's not quite the same thing. But since we have angle 1 plus angle 2 equals 180, then we're going to have the measure of angle 2 plus the measure of angle 3 also equals 180 because of the linear pair theorem. And so then, since both of these are equal to 180, that's your hint that you're just going to set these equal to each other. Measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3, which is the substitution property of equality. If you are abbreviating substitution, keep in mind you need to give me at least SUBS so that I know you're talking about substitution and not subtraction. But then from here, notice we have the measure of angle 2 on both sides. And so we can actually subtract measure of angle 2, which tells me that the measure of angle 1 equals the measure of angle 3 because of the subtraction property of equality. So notice subtraction, I abbreviate with SUBT. So then if these angle measures are equal, my last statement is that angle 1 is indeed congruent to angle 3 because of the definition of congruence. And feel free to use symbols. Okay, so that is number 1. So then for proof number 2, we are given that angle 1 and angle 2 are complementary. So we say angle 1 and angle 2 are complementary. And again, abbreviation is fine. And then angle 1 and angle 3 are also complementary. And this is all given. So then we are trying to prove that angle 2 is congruent to angle 3. Oops, don't know why that line's there. So use your given to come up with more statements. If angle 1 and angle 2 are complementary, then I know they add up to 90. So I'm going to say measure of angle 1 plus measure of angle 2 equals 90 because of definition of complementary angles. Okay. So then if I can say that about 1 and 2, I can say that about 1 and 3 as well. So measure of angle 1 plus measure of angle 3 equals 90 because of definition of complementary angles. And then notice they're both equal to 90, so then I can just set them equal to each other. Measure of angle 1 plus measure of angle 2 equals measure of angle 1 plus measure of angle 3. And that would be substitution because we are substituting in this little bit for this 90 instead. Okay, so then, why is my highlighting not going? There it goes. So then, Once I have that, notice I have the measure of angle 1 on both sides, so I can subtract the measure of angle 1. And when I do that, I get that the measure of angle 2 equals the measure of angle 3. And if 2 equals 3, then that means that angle 2 is congruent to angle 3 because of the definition of congruence again. Okay? So, next proof. Number 3, we are given a lovely picture for this one, but we are told that the measure of angle 2 equals the measure of angle 3. So if you want on your picture, you can draw a little thing. Now I will say technically this picture should have arrows on this line so that you know it's a line, because by knowing it's a line, we can say that the measure of angle 1 plus the measure of angle 2 equals 180 because of the linear pair theorem. We know that if we have two angles that make a line, that it's going to add up to 180, and that's exactly what that theorem says. Oops. Sometimes word is silly. But then we can do the same thing with 3 and 4. So measure of angle 3 plus measure of angle 4 equals 180 because of the linear pair theorem. Okay. And so then with that, they're both equal to 180, so I can substitute and set them equal to each other. So we have measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4. So that would give us substitution property of equality. Now, if you notice, this one is worth 10, so technically we should have 5 steps in each. But this is where I said, sometimes we make mistakes. Sometimes the number may be slightly wrong. I will tell you on the test it's right. But with that being said, technically speaking, this is the part where some people will accept that you can go straight from this reasoning to saying measure of angle 1 equals measure of angle 4 from subtracting 2 and 3 because we already said they were equal. But mathematically, technically speaking, we should say measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 4. Technically, you're supposed to always show that substitution. I am okay if you don't show it on the test. I still will be fine. But that's why this one is technically worth 5, even though technically it should be worth 6 in each. But when you do that, then you can subtract and you get that the measure of angle 1 equals the measure of angle 4 because of the subtraction property of equality. And if you notice from what we're trying to prove, we don't have to say they're congruent, we just have to say they are equal to each other. And again, if you have extra steps on the test, it's totally fine. It's not that it's wrong, it's just that we're trying to give you the minimum number you should have. Okay, so for number 4, we are given that angle 2 is congruent to angle 3. So, given, and we are trying to prove that angle 1 is congruent to angle 4. So, if 2 and 3 are congruent, that's all great and dandy. But we also see that angle 1 is congruent to angle 2 because of the vertical angles theorem. Remember, if you see an X like this, opposite angles are congruent. So then if 1 and 2 are congruent, then that means angle 3 is also congruent to angle 4 because of the exact same reason, vertical angles theorem. So then if you notice, I kind of have a chain. I have angle 1 is congruent to 2, 2 is congruent to 3, 3 is congruent to 4. So therefore, I can say that angle 1 is congruent to angle 4. Oops. Congruent to angle 4 because of the transitive property of congruence. If you can make a chain of statements like this is equal to this is equal to this, to this, to this, then that is the transitive property. You're saying you're going from one thing to the other and keeping that equality or congruence the same throughout. Okay, so for this, forgot we had this page in here. Keep in mind, I may not have used all this stuff from the banks. Personally, the banks make it more for me. I get more confused. But if we look at proof number 5, we are given that angle 2 is congruent to angle 3. So we write that in. Again, even if you don't know how to solve it, write it in so I can give you some credit for it. But we have angle 2 is congruent to angle 3. And kind of like the one above, we have some vertical angles. Angle 1 is congruent to angle 2 because of the vertical angles theorem. And angle 3 is congruent to angle 4 because of the vertical angles theorem. And so then we end up with a chain again. 1 goes to 2, 2 goes to 3, 3 goes to 4. So angle 1 is also congruent to angle 4 because of the transitive property of congruence. Okay. So for number 6, here we go. We have that angle MAD is congruent to angle BAC. And we want to prove that angle 1 is congruent to angle 3. So first, we need to know what the heck MAD and BAC is. So if you come up to the picture, MAD, oops, I thought I was on a highlighter. MAD is this angle right in here, and BAC is this blue angle. And so if you notice with MAD, or the yellow, that's angles 1 and 2, and with BAC, that's angles 2 and 3. So we have some overlap. So because of that, I want to use that to my advantage. And I know I'm going to be substituting, so I'm just going to go ahead and say it now. Measure of angle MAD equals measure of angle BAC. It's one of those duh things that's kind of obnoxious to write, but it is the definition of congruence, and it allows us to use the substitution property later. And even if you're not sure if you need the definition of congruence, you are always free to write it because, again, if you have extra steps, it's not the end of the world. So I'm going to make a statement about the measure of angle MAD. The measure of angle MAD, like I said earlier, is 1 and 2 added together. So we would have the measure of angle 1 plus the measure of angle 2. And that would be called the angle addition postulate because you're saying my big angle MAD is equal to my baby angles added together. Okay? So if I can say that about MAD, then I can do that as well with BAC. BAC is angles 2 and 3. So the measure of angle BAC equals the measure of angle 2 plus the measure of angle 3. And again, angle addition postulate. Okay, so then, oops, I don't know why Word is so bad about this today. So then, since I've said these angles are equal, and since I've made the statement saying what these angles are made up of, I can make the statement that measure of angle 1 plus measure of angle 2 equals the measure of angle 2 plus the measure of angle 3 through the substitution property of equality. Because again, I am substituting in this value up here and this value up here. I'm taking these values and just plugging them in so they're equal to each other. Okay, so we have substitution property of equality. And then you notice we have the measure of angle 2 on both sides, so we can subtract, which gives me measure of angle 1 equals measure of angle 3. Because of the subtraction property of equality, we subtracted measure of angle 2. And so then, because we have to actually specifically say it's congruent, your last and final easy step is that angle 1 is congruent to angle 3 because of the definition of congruence. Definition of congruence allows you to make a congruent sign equal and an equal sign congruent. Lets you go both ways. Okay? So then, for our next one, number 7, we are given that A is 58 and that B is 59 degrees. So we'd say measure of angle A equals 58, measure of angle B equals 59, and these are both given to us, just like that. And we want to prove that the measure of angle C equals 63. So starting off, we can say that since this is a triangle, we know that the measure of all of our angles, so A plus B plus C, is 180 degrees. And that's called the triangle sum theorem. We know that triangles angles add up to 180. So then, because of that, we're going to substitute in our values. Measure of angle A is 58, measure of angle B is 59, plus the measure of angle C equals 180. So that would be substitution property of equality. Then we have to combine 58 plus 59, which is 117. And when you do that combining, remember back to algebra, that would be combined like terms, or CLT. And so then after you do that, we have to subtract 117 from 180. And 180 minus 117 gives us 63. So measure of angle C equals 63 degrees because of the subtraction property of equality. Okay. So I will say that down here, it's kind of missing your options. So if you're like, Miss Hall, we don't have these listed at the bottom, don't worry about it. It's fine. So we have proof number 8 now, and we are given a triangle with interior angles of angle 1, angle 2, angle 3, and angle 4 is an exterior angle. So given this information, we want to prove that measure of angle 1 and 2 is 4. And we cannot use the exterior angle theorem because this would just make it a two-step proof. But what we can do is start by understanding the relationship between angles 3 and angle 4. We know that the measure of angle 3 plus the measure of angle 4 is going to be 180 degrees. Again, there should be a little arrow, but that is because of the linear pair theorem. These make a line together, and with that line, they make 180 degrees. Now, if you notice, 3 is also in a triangle with 1 and 2, which means that those 3 angles will also add up to 180 because of the triangle sum theorem. So we make the statement, measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180 because of the triangle sum theorem. So then, since both of these are equal to 180, we can actually substitute. And since they want 1 and 2 on the left, I'm going to keep them on the left. So measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals measure of angle 3 plus measure of angle 4. And again, we're just substituting in these values. Okay. So then, from there, we have the measure of angle 3 on both sides, so we can subtract the measure of angle 3. And when we do that, we are left with measure of angle 1 plus measure of angle 2 equals the measure of angle 4. And if you notice, that's what we were trying to prove in the first place. Okay? So, next one, 9 through 15. Woo woo, we're getting there. So with this one, we actually have to draw our tables. So statement, reason. So we are starting with angle 1 is complementary to angle 2. And angle 3 is complementary to angle 2. So these are both given. So then if we are trying to prove that angle 1 is congruent to angle 3, I'm going to use the fact that my given says they're complementary to my advantage. I know since they're complementary that the measure of angle 1 plus the measure of angle 2 equals 90 because that's the definition of complementary angles. Okay, so then I can also say that the measure of angle 3 plus the measure of angle 2 is also 90 because, again, definition of complementary angles. They told me they were complementary, so I can use that definition to my advantage. Whoop. So then, since they're both equal to 90, we can just set them equal to each other. And so we would have measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 2. And that is substitution, because we substitute in where the 90 was. And we're going to extend a little bit. Okay, so then if you notice we have the measure of angle 2 on both sides, we can subtract that. So that gives us measure of angle 1 equals measure of angle 3 because of the subtraction property of equality. And then because we're saying that 1 is congruent to 3, you have to make that explicit statement that angle 1 is congruent to angle 3 because of the definition of congruence. Okay? So, a lot of substitution with these if you haven't noticed yet. But we continue on. So for number 10, which on your worksheet, it is the 8 is on the second page, so don't let it mess you up. Just draw an 8. But we have our statements and reasons. So our first statement is going to be that angle 2 is congruent to angle 4 because it is given. Now, if you look at the picture, you'll notice that 1 and 2 are vertical angles. And if you see that, you can just write it. Angle 1 is congruent to angle 2 because of the vertical angles theorem. Boop. So then we do it again, except we have 3 and 4. So angle 3 is congruent to angle 4 because of the vertical angles theorem. And then if I'm trying to say angle 1 is congruent to angle 3, notice I kind of have a chain. 1's congruent to 2, 2's congruent to 4, 4's congruent to 3, so 1's congruent to 3. So this would be the transitive property of congruence. Okay? So then for number 11, we have a triangle with the interior angles again, and we are trying to prove that the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. Statements, reasons. So if you notice, we have triangle, interior angles, angle 1, angle 2, angle 3, and angle 4 is exterior angle. Now, if you notice, this one looks awfully similar to another one we did, and actually it might be exactly the same, but I'm not going to scroll back up. But with this, still the same idea. Can you replicate it? Can you remember it? Because if you can't, then that means you need to study more. But first, and actually I'm just going to do it in a different order just for fun, but 1, 2, and 3 are inside the triangle, so I know that when I add them together, they will equal 180. So that is the triangle sum theorem. Okay? So then 3 and 4, they make a linear pair because, look, it has arrows. So we know the measure of angle 3 plus the measure of angle 4 equals 180 because of the linear pair theorem. Okay? So then we can substitute in measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals measure of angle 3 plus measure of angle 4 because of the substitution property of equality, because again, I just took this and plugged it in where that 180 was instead. So then, after doing that, we have the measure of angle 3 on both sides, and so we can subtract it, which would give us measure of angle 1 plus measure of angle 2 equals the measure of angle 4. And even though it's kind of flip-flop from how they wrote the proof, some people would be really picky. I'm not very picky. It's fine. You can just leave it. Okay? All right. So then, there it goes. For number 12, we are given that NEL is congruent to GES. So I'm going to go ahead, draw my table. Statement, reason. Okay. So angle, NEL or NEL, is congruent to angle GES. So knowing that and knowing that I have to have some equality, I'm just going to go ahead and say measure of angle NEL equals the measure of angle GES because of the definition of congruence. Okay, I'm just going to take my duh thing away now so I don't have to worry about it later. But the reason why this matters is because if you notice at the picture, NEL, N to E to L, is this angle right in here. And then we have GES, which is this angle up here. So it has some overlap. So we can say that the measure of angle NEL is equal to the measure of angle 1 plus the measure of angle 2 because of the angle addition postulate. Again, two baby angles add up to make the big angle. And so if you make a statement like that, it's just that reason. So if I make that statement about the measure of angle NEL, then I can make that statement about the measure of angle GES as well. Except GES is going to be the measure of angle 2 plus the measure of angle 3. But the reason is still going to be the exact same. Okay? So then, since I already said that these two angles are equal to each other, that means I can substitute, because remember, substitution is a property of equality, and so you have to have an equal sign if you want to use it. Okay, so measure of angle 1 plus 2 equals 2 plus 3, and that is the substitution property of equality. So then, notice we have the measure of angle 2 on both sides. We can subtract it so that we get the measure of angle 1 equals the measure of angle 3, again because of subtraction. And then if the measures of the angles are equal, then we know angle 1 is congruent to angle 3. Why is it not writing? Angle 1 is congruent to angle 3. And that is because of the definition of congruence. Voila. Okay. So for number 13, we have to prove that A and C are complementary. So we're going to do, why does it change so slowly? So we have triangle ABC, and angle B is a right angle. Okay, so if B is a right angle, you can say the measure of angle B equals 90 degrees because that's the definition of a right angle. Okay, so then if we know that B equals 90, we can make a statement about all of these angles added together. The measure of angle A plus the measure of angle B plus the measure of angle C would be 180 because of that triangle sum theorem. Okay. And so then I have the measure of angle B is 90, so I can substitute that in and have measure of angle A plus 90 plus measure of angle C equals 180 because of substitution property of equality. And then, if you haven't noticed, a lot of the times after substitution is my reason, my next reason is going to be the subtraction property of equality, and that is because we usually subtract. But that would give us measure of angle A plus measure of angle C equals 90. And so then, if added together they're 90 degrees, that means angle A and angle C are complementary to each other. Angle complementary because of the definition of complementary angles. Okay, they add up to 90, so I know they're complementary. All right. So then for number 14, I will let you know that I think this has more steps than 14 pieces, but we draw our line, and I'm really sick of these lines not changing colors. But we have our statements and our reasons. So we start with angle FRM is congruent, oh goodness, to angle FMR. are. And yes, they are different. And then we also have angle 1 is congruent to angle 3. So I'm going to get my duh things out of the way. I'm going to say that the measure of angle FRM is equal to the measure of angle FMR because of the definition of congruence. And then I'm going to go ahead and make my life even simpler. Measure of angle 1 equals measure of angle 3 because of the definition of congruence again. Boop. So then, if you actually look at the picture, because notice I got those three just from the given, but FRM is this guy, and it's made up of 3 and 4. And then you have FMR, which is this guy over here, and it's angles 1 and 2. And so, because of that, we can use our angle addition postulate to say that the measure of angle FMR equals the measure of angle 1 plus the measure of angle 2. And that is just that angle addition postulate again. So then, if I can say that about FMR, then I can do the same thing about the measure of angle FRM. And that one's going to be the measure of angle 3 plus the measure of angle 4. And again, angle addition postulate. Okay? So then, with that, I know that these angles are equal. I've already said they're equal. So that means I can substitute measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4. And we're allowed to do this substitution because we've already gone through and said our duh things. Okay? So then, almost there. I want black, not green. There we go. So then when we have that, since we said 1 equals 3, we can substitute measure of angle 1 plus measure of angle 2 equals measure of angle 1 instead of 3, measure of angle 1 instead of 3, and then measure of angle 4. And that is, again, substitution, property of equality. But the reason behind this is because then we're going to subtract the measure of angle 1, which tells me that the measure of angle 2 equals the measure of angle 4. I'm sorry that this got so smushed. But then if angle 2 equals angle 4, then we can say angle 2 is congruent to angle 4 because of the definition of congruence. Word is not happy with me. Maybe. There we go. All right, there we go. Okay. Okay, statement, reason. We can do this. Maybe. Okay, so we will start with angle 2 is congruent to angle 4 because of given. Yay! So then if angle 2 is congruent to angle 4, I can also say angle 5 is congruent to angle 6, like I was saying, because of the vertical angles theorem. Boop. And so then we're going to throw in our duh comments. Measure of angle 2 equals measure of angle 4 because of the definition of congruence. And we can also say measure of angle 5 equals measure of angle 6 because of definition of congruence again. Yay! And the reason why this is helpful is because I can say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 5 is 180. Why? Because of the triangle sum theorem, of course. Triangles add up to 180. All of the angles add up to 180. And so we can make the same statement, just different numbers, with the other one. Measure of angle 3 plus measure of angle 4 plus measure of angle 6 equals 180 because of the triangle sum theorem. So then you notice I already said my duh things, and the reason why is because then I can just substitute them in. Since these are both equal to 180, this is going to be your step that probably looks the worst, but measure of angle 1 plus measure of angle 2 plus measure of angle 5 equals measure of angle 3 plus 4 plus 6. Now, even though that looks, why did I put theorem? Even though that looks bad, you're really, again, just substituting. It's just that you happen to be substituting things that are slightly longer to write out. But when you do that substitution, we then have to substitute in 2 for 4 and 5 for 6. So measure of angle 1 plus measure of angle 2 plus measure of angle 5 equals measure of angle 3. Measure of angle 4 can be replaced by the measure of angle 2. And measure of angle 6 can be replaced by measure of angle 5. So again, substitution, because we substituted in the values we said were equal earlier. So then we have measure of angle 2 and the measure of angle 5 on both sides. So we can use the subtraction property of equality to get that the measure of angle 1 equals the measure of angle 3. And then by doing that, because remind yourself that we have to say 1's congruent to 3. So then my last statement, I'm going to extend my line a little bit, is that 1 is congruent to 3. Angle 1 is congruent to angle 3 because of the definition of congruence. Okay, so that is the end of your proof practice. Like I said before, if you get these proofs down and you are super comfortable and can replicate them easily, then the test should be easy for you. A great way to study for this beyond just watching a video about it is to try the proofs again, cover up the answer, see if you can replicate it, and if you can't, you just need to study more. So if you have any questions, just comment below, give the video a like, subscribe to the channel so you can get notifications of when other videos are posted, and if you have any questions, again, feel free to ask. I am more than happy to answer any and all questions.